Hi guys, this is Mayurvad. Welcome back to another video on my YouTube channel. In this video, we are going to design an online auction system. You can expect exactly similar questions in your low-level design SDE interview rounds. In this video, we will see how we can apply OOPS concepts, solid principles and design patterns to come up with a design that is robust, extensible and easy to refactor. We will see the class diagram and we will also code the entire system. Before starting, just wanted to tell you guys that this video is part of our design patterns and low level design series. In my coming videos, we are going to solve many more such low level design questions. Also, I am going to add videos where we are going to discuss the most popular and most commonly used design patterns. So if you are interested in such kind of content, I recommend you subscribing to my YouTube channel so that you get notified whenever I upload a new video. So let's get started. So whenever you get a low level design question, the very first thing which we do is to clearly understand all the requirements, right? So go through the problem statement very carefully and try to clearly understand all the requirements and all the functionalities which interviewer is expecting from our system. Also here, do not make any assumption, right? So if you have any doubt, if you are not cleared about the requirement or the functionalities, try to clarify it with the interviewer at this stage of your interview, because you don't want that you basically make an assumption and code a system and then interviewer was expecting something else, right? So it is very important that you clarify all your requirements. In this video, we are basically designing an online auction system, right? And since this is our first video on low level design questions, I have kept the minimum requirements. So these are the requirements. Please go through them and try to understand the requirements. So once you have clearly understood all the requirements and what interviewer is expecting from us, try to identify the functionalities which our system should support. You can also basically create a use case diagram which will help you to identify all your functionalities based on the problem statement given. But in an interview, we usually don't have that much time. So you can skip this step of creating the use case diagram and just directly jot down the functionalities which you think your system should support. Now, second step to approach a low level design question is to identify the core classes, right? So in our system, we can have multiple classes, but at this stage of our interview, we just try to identify the core classes. Now, how can we identify core classes? So basically go through the requirements, go through the problem statement, and the nouns present in your problem statement in your requirement can be your possible candidates for core classes. While designing this online auction system, based on our requirements, we can clearly see that we will have three core classes. One will be our seller class, one will be our buyer class, and one will be our auction class, right? Once we have identified our core classes, try to basically identify the relationships between your classes, how the objects of your classes will basically interact with each other, right? And try to basically identify the abstract classes, the interface which you will be creating. Try to identify the inheritance if you are going to apply anywhere. One very important thing over here is try to apply a design pattern if your design pattern solves a particular problem which is given in your requirements. Now, as mentioned in our online auction system requirement, a seller can initiate an auction. One auction consists of one product. A buyer can subscribe to an auction and a buyer can bid in an auction. So one seller can own multiple auctions. One auction will only consist of one product. Multiple buyers can bid in multiple auctions and multiple buyers can subscribe to multiple auctions. Also, in our online auction system requirements, it is stated that whenever the state of the auction changes, we need to notify all our subscribers. So it is one classical problem which observer pattern solves. So here our auction class will basically act as a publisher and The buyer and seller will basically act as the observers. So in an interview, it can happen that you don't have that much time to create a class diagram and you have to start with the coding of your system. Then basically just try to create a very rough class diagram, or if you have visualized the class diagram in your mind, you can skip this. So once you have identified all your core classes, start with coding. The very first thing which we should code are models. So models are nothing but your core classes which we identified. Okay, so let's look at the models first. So I've created a user class and added all the fields that were specific to the user in this class. Now this user class will be inherited by our buyer and seller classes. So all the user level data like user ID, username, email ID, phone number, all that is added in this user class. All the fields that are common in both seller and buyer. Now we can also add more details here, like we can add address and user bank account details. So if I would have added that, I would have taken it as a list because a user can have multiple bank account details and multiple addresses. But to keep the model very simple and very basic, since this is our very first low level design video, I have kept the minimum fields. In our problem statement, we had a basically requirement that whenever the auction state changes, our sellers and buyers should be notified. So I have also kept a list of notifications over here. For that, I have created fields that are specific to notification. Now in this notifications list, the one thing which we need to take care is that we always insert latest data at the head of the list. So in this way, whenever we will traverse the list, we will always get the latest notification first. Now let's look at this notification class. So in this notification class, I have just kept the date when the event happened and the message. We can also add more details here. Let's now look at our main models, that is our buyer and our seller. So if we look at a seller will basically have a list of all the auctions that are basically owned by the seller. That specific data I have added in the seller class. Now there can be other data as well, which we can keep on adding in the seller model, right? All the seller specific data will come here. Similarly, buyer class will also inherit the user class because we need all user level data at buyer. Apart from that, in buyer class, we will also have to maintain all the auctions to which the buyer has subscribed. Also, we need to keep the track of all the auctions in which the buyer has bid and what is the bid amount placed by that buyer. This information we will basically require for implementing some of our functionalities. Like, let's say we want to implement a functionality in which a buyer can view all the bids which he has made in all the auctions. Also, another requirement of this data will come in functionality when a buyer will place a bid. So when a buyer will place a bid, we need to check that the current bid placed by the buyer should be greater than the previous bid placed by that buyer in the same auction. So for that, I have taken a map where our key is a string. This will be basically our auction ID, and then I have as a value taken a map of string comma double. So now currently as per our requirements, whenever a buyer bids in an auction, it automatically becomes the subscriber of that auction. So this subscribed auctions data member is serving two purposes for me. So whenever a buyer basically subscribes to an auction but hasn't bid in an auction, I will add it here. So I will add the auction ID as the key and I will add an empty map here, right? But whenever a buyer bids in an auction, at that point of time in this map, I will keep the product ID. This product belongs to this auction, and then the bid that buyer has made. So whenever a buyer has just subscribed, it will be an auction ID and an empty map, right? But when buyer basically bids in an auction, it will be auction ID, and then in this map we will have the product ID, product belonging to that auction, and the bid made by that buyer, right? So now this I have done because currently, as per our requirements, one auction can only contain one product, right? But let's say in future we have a requirement that an auction can contain multiple products and a buyer can bid for multiple products in an auction. We need to store the bid value for every product separately. So we need to keep a track of product ID as well as the bid value which buyer has made for that product ID. So in that case, if this requirement comes up, there will be no change in our model. Our currently existing model will only work. So this data member is basically serving these two purposes. It is holding both the datas, the auctions in which buyer has subscribed but yet not made any bid. Also, it is storing all the auctions in which our buyer has made a bid, right? Now, these are our three main models. We have also seen our notification, right? To to other classes like event and auction product, we'll see. Now, another main model is our auction class, right? So in auction, we have stored all the auction level data. So whenever our seller will basically draft an auction, we will create a new auction which will be instance of our auction class. Now this auction is basically a publisher because whenever the auction state changes, we need to notify its subscribers. So auction is a publisher and its subscribers will be our seller and our buyer. So in auction, we have an auction ID, which will be unique for each auction. We have a seller ID who initiated that auction, right? We have auction state. Here, auction state is basically an enum. So we have multiple auction states like drafted, when auction is in draft state and seller can still edit the auction. We have published state. That means when the seller has made the auction live, right? So seller cannot edit the auction, but the auction is still not started because seller has scheduled some start time and end time, right? Started is when auction is in progress. End failed. So we had a requirement that if the reserve price defined by the seller is greater than the final bid, then we should fail the auction, right? So it is that state. And end success. And then we have start date and end date, right? Now each auction will have one product as written in our requirements. So we have taken a list of products where this will be a singleton list. That means this list will only have one item. You can imagine that there is just one object inside this list. So size of this list can be maximum 1, right? That we will make sure entirely while coding. So why I have taken this as a list instead of just an auction product is because in future it may happen that we have a requirement, we need to extend it so that an auction can have multiple products. At that point of time, there will be no change in the model, right? This model will as it is work. Now let's have a look at this auction product also. So auction product is basically a product, right, with the details specific to that product for that auction, right? So it's not specific to the product. So it's not a product name or product description, but it's something data relevant to the product when the product is added to an auction. So when a product is added to an auction, a seller can define a base price, right? So for each product, we can have a base price. So in future, if we have multiple products, seller can define base price, right, for each product. We have auction product state. So to track the state of the product, if the product is unbid, if it is bid but unsold, if it is sold, and if it is failed. Failed means that if auction fails, then this auction product state is also marked as failed state. So we have current bid, which is the amount which is currently set for that product, and who has made that bid, which buyer has made that bid. That buyer ID we will store in current winning buyer ID, right? Now these two details also why we have kept that in auction product and not in auction class is because of the same reason. In future, if an auction can contain multiple products, right? So for each product, we will have to trace the bid and who has made that bid, because it can happen that for one product I have made maximum bid and for another product someone else has made the highest bid, right? Okay, now auction also extends the publisher. So let's have a look at our publisher class. So in publisher, we just have a map of observers, right? So as you all know, in observer pattern, the publisher maintains a list of observers. So here we have taken a map of observer type and list of string. This string will basically be the ID of that observer, like seller ID or an buyer ID, right? So observer type, we have three observer types. One is seller, buyer, or both, right? So when observer type is both, that means we have to notify both seller and buyer. When observer type is seller, we just have to notify the seller about the state change, and when observer type is buyer, we have to notify buyer about the state change, right? So in this publisher class, what we do is basically this map will have two keys, that is your seller and buyer. So whenever a buyer subscribes to an auction, we will add it to this list that is mapped to buyer key, right? And in the list which is mapped to seller key, we will add the seller ID, seller who owns that auction. This is our publisher class. After we are done with creating models, the next step is to create services and repositories. So in our system, we need to store data. So in a low-level design, since our primary focus here is to design the models and functionalities, we use in-memory data structures to store all our objects. That is the entire data of our system. So for our online auction system, I have basically kept a hash map where key is ID and value is object. So in case of buyer, key is buyer ID and value is buyer object. In case of auction, key is auction ID and object is auction. So now, given buyer ID as input, I can basically find and access the corresponding buyer object, and so I can get corresponding buyer data. Buyer hash map is kept in buyer repository. Similarly, we have auction repository. Similarly, we have seller repository where we have a hash map to store seller objects. Here, we have used Singleton design pattern as we want to have a single instance of each repository that should be shared across all the services. Now, service is where we have our functionalities which are system support. Service gets data from repository, executes some business logic on that data, and returns the final processed response. Now, in our online auction system, we have three main services. Auction service, which contains functions to support auction related functionalities. Seller service, which contains functions to support seller related functionalities, and buyer service, which contains functions to support buyer related functionalities. Now, a functionality of, let's say, placing a bid is related to auction, so it will be coded in auction service. Similarly, the functionality where we have to display all the auctions to which a buyer has subscribed is related to a buyer, and so it will be coded in the buyer service. Now let's look at our services. So when we started our video, we went through few requirements which were given to us by the interviewer, right? And we noted down some functionalities which our applications should support, right? Now all those functionalities will be written inside our services. Now a functionality specific to an entity will go in that entity's service class. Like for a buyer, if a buyer wants to view all his or her bids, right, or all the auctions in which that buyer has subscribed, so that functionality will go inside our buyer service, right? Or if we want to add a new buyer, that functionality will go inside our buyer service. Similarly, the functionalities which are concerned with the auction, right, will go in the auction service, like placing a bid in an auction, right, will basically go in an auction service. Now we try to keep our services stateless. That is, we don't store any data in our services. Instead, I have a repository folder where I have different repositories, right? Like I have a seller repository, which will store all the sellers who have registered in our application. We have a auction repository, which will store all the auctions which we have in our application. We will have a buyer repository and similarly a product repository, right? Now if we look at our seller service, any of the functionality of seller service, let's look at get notifications, let's say. So first we will validate the seller, right? Once the seller is validated, we will iterate the notification data structure, right, the list of notifications which we kept, and we will keep on adding the notifications and then we will return it. So here I have kept a maximum limit on the number of notifications that we want to give to the user. So at max we want to return only 10 notifications, right? So these are some of the functionalities of our seller class. I highly recommend you guys to clone this repository from GitHub and go through it once. You will get a lot of understanding on how do we write a functionality, right? How can we apply design patterns that we are going to see in this video as well. We are going to see how we implemented observer pattern and strategy pattern, right? Singleton I already showed you. In repositories I have used singleton pattern. Let's check the code for 3 of our core functionalities. When a buyer wants to subscribe to an auction, when a buyer wants to unsubscribe to an auction, and when a buyer wants to place a bid, right? So let's start with the subscribe and unsubscribe functionality. Both of them I've kept in buyer service. So when buyer wants to subscribe to an auction, right, we have taken the buyer ID who wants to subscribe and which auction the buyer wants to subscribe. So first we have validated the buyer, right? Then we get the buyer object from our repository. Then we check if buyer has already subscribed. So we had a map of subscribed auctions, right, in our buyer model. I'll show you again. So in our buyer model, we have a map of subscribed auctions. So if key is present, then buyer has subscribed to that auction, right? So if key is present, then buyer has subscribed to that auction. If not, we will first try to make changes in our publisher. So if you remember, in observer, publisher stores the list of observers, right? So our publisher here is our auction. So we will call an API of auction service, right? So if you remember, serve publisher basically expose 3 functions: subscribe, unsubscribe, and notify observers. Usually we call register and unregister instead of subscribe and unsubscribe, but here I've used subscribe and unsubscribe. So we will call the subscribe API of auction service. Here what we are doing, we are just adding that auction ID to the list of observers which our publisher maintains. So here we have also passed the observer type, right? So in buyer service, we will pass buyer as an observer, which is nothing but observer type dot buyer, so that in our publisher model, for the key when observer type is buyer, in that list we add our buyer, right? Similarly, we have an unsubscribed flow written out here. You can check that out. And similarly, we have a place bid, right? Place bid will be in an auction service, because in an auction we are placing a bid, right? So basically in place bid, what we'll do, we'll first validate both auction and our buyer. After that, we'll see if auction product exists, the product in which the user wants to place a bid, if that product exists. Then we'll see if auction is in running state, and if it is in running state, then the bid value which we want to place, that bid value is greater than the current bid, right? And then we'll place the bid. We'll also call buyer service here, because in our buyer also we want to add the auction, right, in which the buyer has bid. So if you look at the buyer model, here also we are maintaining a map of subscribed auctions, where key is the auction ID to which a buyer has subscribed or a buyer has bidden, right? Now let's go through one more functionality, that is whenever a state change happens, we want to update our observers, right? So let's say someone has placed a new bid and we want to notify it, right? So basically we will, after all the logic on placing a bid is done, we will call the update observers method. Now here we have an event, right? Event is basically the object what we are passing to observers, from which observers can get data. So in an event, I have a message and a data type and an event type. So this event type is auction started, auction end, or new bid value updated, right? Or bid value updated or new bid placed. Both are same. So in an auction service, we'll first create an event. Since this update observer flow is when a new bid is placed or bid value is updated, we put the event type as bid value updated and we create a new event, right? And then we finally call our update observers method. So if the observer type is buyer, we will only update the observers who are in your who are mapped to your buyer key. And if your observer type is seller, we will only update observers who are mapped to seller key. So that we are doing here. I would highly recommend you guys to clone this repo and make code changes. Try to introduce your own requirements, then try to identify the functionalities to fulfill those requirements. Now, if you require some new models, try to add some new models, right? And try to apply design patterns while you are implementing your functionalities. So in that way, you will get better and better in your low level designing. When we started our video, we had one additional requirement, which is good to have requirement, right? I would recommend you guys to just try implementing that auto bidding system, right? How can you implement it, and how can we add more functionalities to an existing database? That will be a very good exercise. If you find this video helpful, please like it and share it with your friends. Also, do subscribe to my YouTube channel for more such content. If you have any doubt regarding whatever we have discussed in this video, you can comment down in the comment section and I'll try to address it. Also, I've started a Telegram group where we can discuss low-level design questions, our design implementations, as well as coding questions asked in interviews. So if you are interested, you can join. Link to the Telegram group is in the description section. See you in the next video. Till then, bye bye. Take care.